Right then, this evening we're going to be looking at fluid power. Now what that means for us is pretty well pneumatics. Now there is some debate around WA as to whether pneumatics is going to be an instrument problem or it's going to be a fitter's problem. Fact of the matter is that this course will give you a certificate 4, and with a certificate 4 you're no longer stuck in your trade. So it's aimed at the supervisor who'll be in charge of several tradesmen. So you need to know about pneumatics. Also, if you go to other states and you go to other countries, pneumatics is very much a part of instrumentation. So we're going to look at some of the pneumatics and some of the problems we have with pneumatics. The first thing we need to talk about is the source of our pneumatic power. The source of our pneumatic power is effectively, it's a compressor. Now, as instrument people, we need to take an interest in the compressor. Here's a typical compressor. This one's actually in remarkably good order. Now, as you'll notice, there's oil here. The man who looks after the compressor, his job is to make sure that it makes a noise. If it ever stops making a noise, he gets the oil and he pours it into whatever orifice he can find. This compressor has got to give us compressed air. Compressed air must be clean. Above all else, it must be clean, which means no dirt, no oil, and no water. Now, some of you may already work on sites where you are dealing with compressed air, and in a lot of places, it's absolutely terrible. It's full of dirt, it's full of oil, and it's full of water. If that's the case, you're going to have problems with your pneumatics. Now let's have a look at a few compressors so as you become familiar with them. The first type of compressor is a reciprocating compressor. It works just like a car engine. You have a big piston inside a cylinder, and that goes round, and as the shaft goes round and round, the piston goes up and down. Air comes in and air is compressed. Simple reciprocating compressor. What we always have to ask ourselves about compressors is, what do we do with the compressor when we've reached enough air, when there's enough air pressure? This is a type of compressor you might go out to like Bunnings or something and buy a small one. With a Bunnings compressor, a small one, when it gets up to pressure, a pressure switch just switches it off. With this type of compressor, why do you suppose we can't just switch it off when we've got to pressure and switch it back on when we need more pressure? Yep, that's the thing. If you start this thing up under load, all that's going to happen is the motor will start up, there'll be an awful lot of screeching, the compressor house will fill with smoke, and you'll melt the belts. You cannot start this thing under load. What this has is, these things here, and these things here, they're called unloaders, or decompressors. What they do is they open up the piston. They open a hole in the piston, and then what happens is the piston just goes up and down and doesn't do any compressing. If you need to start these things up, the first thing you need to do is trip all the unloaders so that it's not starting up under load. What we typically do with these is we run them continuously, and when we get to enough pressure, the unloaders automatically flip open. That might seem a little bit wasteful, and that's because it is quite wasteful. Generally speaking, making compressed air is a very wasteful thing to do. It's an expensive thing to make. The second type of compressor I want to look at is the screw compressor. This is like two corkscrews that fit into each other, and they rotate in different directions. That one rotates that way, and this one rotates that way. And as they rotate, air is pulled in at that point and pushed along the screw and ends up over there being compressed. To unload one of these, what you have is underneath it, so I'll just draw it in cross-section. There's the screw, and as it compresses it winds that way. Underneath this, there's a thing called the slide. And the slide slides outwards. And as the slide slides outwards, it exposes the screw. So it reduces the amount of compression that it can do. So with a screw, we can slide the slide out and reduce the compression. Now with a screw, looked at end on, we've got one screw there and another screw there, and they're overlapping. And they're all very tightly inside their casing. It's very, very tight fit inside its casing. Now, can anybody see any potential problem with having two screws which are rotating very fast as in a very, very tight fitting case? Yep, it's going to wear. It's going to get hot and it's going to wear. The solution, of course, is to put oil in there. Oil also serves as a really good seal. When you put oil in, you get much better compression because the oil seals. So instead of having metal-to-metal surfaces, we've now got oil in there. It cools it down, stops it wearing. Superb. Here's a diagram of a typical screw compressor. This section here, that's the actual screw. The rest of it is oil recovery, because remember, we are not allowed to have oil being delivered, so there can be no oil there. So here is this bit here. That's where we actually do the compressing. The rest of this is to get the oil back out. The oil is taken back out and returned back to the screw. You can get oilless screws, but they get much less compression with an oilless screw. So this is a typical screw compressor, and it's an oil screw compressor. You get good compression. It runs quite efficiently, but you have this massive oil recovery system. Every now and then, for reasons I don't know why really, something can go wrong. And what will happen is this entire tank of oil gets kind of burped down the oil line. It's called dumping its load. Now that's quite a catastrophic thing to happen, because then we've got oil throughout the entire pneumatic system, and that's a big problem. The next type of compressor I want to look at is the centrifugal compressor. With this one, air is drawn into the center there and spun outwards as this disc rotates. Probably spun outwards that way, and compressed air ends up going up there. Centrifugal compressors are lovely. They're not as efficient as screws. They're very, very quiet. Screw compressors scream like banshees. They're horrible things. But a centrifugal compressor is lovely and quiet. There's no oil involved anywhere. It just runs nicely. To unload a centrifugal compressor, we have these vanes. They're called inlet guide vanes. And this is an inlet guide vane. The inlet guide vane sits at the throat here. And what it does is it opens and closes like blades on a propeller feathering, and it allows the air to come in, or chokes it off basically. Oh, now one thing I should mention, throughout all this I've been talking about unloading compressors by inlet guide vanes and slides. Nowadays, of course, there's another method we have of unloading a compressor, and that's by changing the speed of the AC motor. How do you go about changing the speed of an AC motor nowadays? Variable speed drive, or variable frequency drive, or in Europe they're called inverters. So nowadays we can VSD. So increasingly nowadays compressors are coming fitted with VSDs, and we just wind the thing down instead. That works really quite well. You also get rotary vane compressors. They're quite popular. I don't want to go into too much how that works. Basically, this thing rotates, stuff is drawn from down here, and it's compressed as it goes up here, and it ends up going out of there compressed. Works very similar to a Wankel engine, and it has the same sort of problems with the vanes. The vanes here, they have a tendency to wear. They also have a tendency to, as they do wear, they tend to put dust out into the system, which can be a problem. Here is an extremely nice 5-stage centrifugal air compressor. Now, 5 stages means the outlet of one compression stage is fed into the inlet of the second compression stage, and it goes along in 5 stages until we get the compression that we require. This big box here, this is the filters. On the other side of here are huge bag filters. Now, one very common fault we get is that we monitor our bag filters. So I'm just going to draw a bag filter. There's my bag filter. I'm going to monitor my bag filter, DP across my bag filter to monitor it. And the idea is that every day I plot this, and as the DP rises, when it gets to a certain point, I will go in and change the filter. Okay, my DP's coming up, my DP's coming up, my DP's coming up. And then, oh, lo and behold, the DP drops right off. So I don't need to change the filter. Why has my DP dropped right off? Nobody got any ideas? As the filter gets gradually dirtier, as dirt builds up here, the pressure across the filter builds up, so the DP goes up and up and up. And then, for some reason, my DP has dropped right off. Okay, what's happened here? There's a hole in the filter. If a hole blows through the filter, and that's quite a common thing to occur if the filter's getting blocked up, if a hole blows through the filter, now there's no DP above it, across it. If there's no DP across it, then the person looking after the filters says, well, I don't need to change them. Of course, that's silly. He very much needs to change it. So something you should always be aware of is when we're monitoring DP across filters, we have to have a high limit, and we also have to have a low limit. So that if the DP ever goes below the low limit, that would indicate that the filter's got a hole in it. Since we're increasingly doing this stuff on PLCs, when you set up your PLC, you need to make sure you set up your PLC to monitor for a high limit and to monitor for a low limit. So that's something to bear in mind. Here's a typical compressor that's been put onto a PLC with a SCADA system. And this is what we're going to be doing increasingly. So it really is becoming part of instrumentation's territory. When we're setting this up, once again you set up the filtering to check for high and low limits. One reason why there's a push to computerize compressors is because it is just so very expensive to make compressed air. And if there's any way we can do this more efficiently, then we will.